First thing I will show you is the calendar. Um, and I did get through all the quizzes, and they're really good, except for those that I told you. If you ain't gonna do your homework, I have a pretty good progression of those that didn't do their homework, did not do well on that quiz. It's very simple progression, right? And I will put those in, the grade book today, at some point. But most people, it's like we're high 30s out of 36, and expect that. So that is good. I do like that. We are doing the job. Guess what? You're gonna have to do it again. Because we do have some bad scheduling coming up. I can't believe it. We're a week away from being done for spring break. Going to spring break. So we're going to do it again. You're going to have a quiz a week from tomorrow. All right. You can be ready for it or not. Again, you're going to have to really hunker down and daily do your homework. And if you make those decisions again, guess what? You're not going to pass, and it's going to be another bad grade. But I will synthesize the chapter a little bit more than last year. We did kind of cut it down compared to last year, but last year I dragged it out. It was a little too lengthy. When we talk about circles, what do you think C stands for? C stands for what? Circumference. So I'm going to throw some things that you're supposed to know down. Circumference is 2 pi r. I don't know if we already covered that because we already talked about circles earlier, but that was just equations in a coordinate plane, so maybe not. What's 2 radii, which you learned from your video yesterday, unless you didn't watch it. So diameter, as a matter of fact, with my pi shirt on, just told the story why I have this pi shirt on. You don't care on the internet. But that's how you find pi. You literally measure the outer edge of a circle. You get that measurement. You measure the diameter. You divide those two. The magical 3.14 comes about. All right. But anyway, I'm probably going to more so use that formula. And then this one. And then these come about at the end of this chapter, the third and the fourth subject matter. So I want to synthesize the chapter. This is today. One, we're going to be doing circles and with a whole thing on angles. What are angle measures? And there's a whole bunch of different possibilities, and I just don't want to get into it. We'll get into it today. And then number 2, circles. But now we're going to do lengths, I guess is the best way. Not per se with circumference, lengths of certain segments in a circle. That's tomorrow. Okay, so we'll have angle measures, we'll have lengths. And then the third concept actually is with arc lengths, not arc measures. We'll talk about arc measures today. Arc lengths are actually feet, inches, miles, and they're related to circumference. We have one whole day of dealing with that. And then the last day is area. But it's not just going to be a simple, pi r squared questions. A whole bunch of different areas of circles. Areas of just sectors, which is a piece of the pie. And then areas of segments, which is a weird little portion of the circle. And then multi-area questions, circles inside of squares, or 9 circles within a rectangle. What's the area of the shaded region? So, we're going to get into all of that in the last situation. Okay, now, you have all these given, correct? You have all these written down on your paper, right? Okay, a couple things to maybe add to this. How is a secant and a chord different? A chord, the endpoints end at the circle. This was in your video yesterday, where a secant is a line that passes through the circle on both ends, and it crosses twice. Now, sorry, I should turn this so you at least see that I'm teaching at the screen. Double whammy on a double screen there. One thing you want to mark, because this does come up randomly like later when we go into the review. I may not have these questions today, but you need to know that when a radius, and that's what this is actually, half a diameter, this is a radius. When a radius hits a tangent line at its point of tangency, circle that. They have to be perpendicular. All right, so that has to be a 90-degree angle measure there. All right, and then one more thing. How is a tangent line more special than a secant line? A secant line, there's like an infinite amount of secant lines that pass through this point. Secant line, secant line, secant line. Those all three are secant lines going through this particular point. A tangent line, there is one and only one tangent line that passes that point on that circle. Soon as I turn that a little bit, it becomes a secant line. All right. So tangent lines are very, very special. All right. They're very special. All right. And then that's one special scenario there. Pre or calculus teachers love the tangency idea, and a lot of things come from that tangency. One thing you want to really mark here, I don't know if the video talked about this yesterday, but that's an arc. All right, so we're going to do two things with the outer edge of the circle. Today, we're going to give them degree measures. Tomorrow, wrong. Day 3, we're going to talk about length of that arc, like in feet, inches, miles, which is way different than degree measures. Let me ask you a simple question. When I say what's a full circle, what does everyone say in degrees? 3, 2, 1, go! 360. All right, so that's what we're going to do. We're going to bust this up, this arc measure from there to there. Is everyone okay over there? I heard it now. That is 360 degrees. All right, so we're going to put arc measures on the outer edge of the circle. All right, and that's what our next set of notes are. So that little arc there is a kind of a small measure. All right, and then we're going to move on from there. All right, go ahead and mark your circle like this because we ain't got no time. We actually just have a couple things to memorize today. Fumble over there. So I want to do my job. Okay, so what you need to do is get those letters so your letters correspond to mine. And all I did is I just decided to start here and I went A, B, C, D, E, F, G. And then I called it Circle O with that big obnoxious point in the middle. All right, and then I'm not going to draw or write every single one of these down. But some examples of radii are OA. I got to get my pen activated. Let me do a different color. OA. And I'll put a little segment above that. OB or BO. Or, I don't know, OG. What's 06? All right. I do have a problem with G's and looking like 6s. Or GO, go, which I'd like to say to that student first hour that chucked something at me. Go out of my class forever. I never want to deal with you ever again. Should have that right. Someone capable of such a nefarious. Everyone's laughing. A diameter. There is only one that is drawn here, and that is GC. Go. GC. All right, and then what's a chord? It looks like I have a couple drawn. FD is one. Actually, GC is a chord. It's just a special chord. It's a chord that goes through the center, which is actually a diameter. And then DE is another possibility. All right, just giving you an idea what these are. This was from yesterday's video. But now we got some stuff here. Now listen, what's a full circle? What's a full circle? How many degrees is that? 3, 2, 1, go. 360. Don't start panicking. Oh, unit circle, clockwise. No, we're not. That's done. All right. But we know full circle is 360. So this arc measure, that's not what I wanted. I don't know how the eraser came up. All right. This arc measure from here all the way around is 360. All right. So then there's a definite relationship. This angle right here is a central angle. So that angle right there is a central angle. The vertex is on the center itself. Central angles, this measure is equal to this measure because they both, when we think about a whole circle, add up to 360 if I did the full rotation. When I do the full outer edge of the circle and I assign degrees on it, a full circle is 360 as well. So this is, and I actually display that in the next slide or the next thing. What are these actual measures? AOB, O has to be in the middle, is a central angle. So I don't want to mark this up too much. There's a whole bunch of them. I'm not writing them all down, but GOA and then BOC. I don't know. There's a few more. I could actually say COA, COA, right? That little obtuse angle there, so on and so on and so forth. And then the idea of, inscribed angle. Okay, now let's think about this. Let's think I grab this. If this is equal to this, What happens if I grab that vertex and I pull it like a rubber band and pull O all the way to this circle point right out here? What happens to this angle measure then? Does it get bigger or smaller when I pull that vertex backwards? Go ahead and say bigger or smaller. Three, two, one, go. It's common sense that that becomes smaller. So what I did is I turned this into an inscribed angle. There is no way that this measure is equal to that measure. All right. Now I'll tell you what it is on the next slide. Just you're going to have it memorized. But I only have one inscribed angle drawn on this, and that is FDE. I should have put a formal definition for it. An inscribed angle is when the vertex is on the circle itself, not the center. I wanted to cover that because these two are not equal. It's actually very simple what they are. But this angle is smaller than that arc because this angle is equal to that arc. When I pull that vertex back, the angle shrinks because of the rubber band idea. All right. Common sense. So, like what I try to be for a teacher so that you understand things better. If you don't like it, well, I can't help you. All right. Minor arc. Okay, a minor arc is an arc that's less than 180. So therefore, a major arc is one that's greater. We got a problem though. We got to name these certain ways. First of all, to name an arc, we need an arc measure above it or an arc symbol. So when I say GA and that's an arc, I need an arc symbol above that. And you'll see that when I go into the formal examples, like what we got to do with this stuff. All right. So again, this can be pretty direct the next 4 lessons because we got a quiz a week from tomorrow. It's really just based off of knowledge. Really nothing to it. You're either going to decide to figure this out or not. I can do this a billion times, not a billion, but quite a bit. Here's another one, A, B, and a whole bunch of other ones. I could do this all day. Okay, now, what is this measure from here to here? What is this measure from here to here? 3, 2, 1, go. 180. That's a semicircle to the right. But notice I went on the right side of the diameter. And a diameter is going to, be the separator between semicircles, half of one circle, half of the other. So can I just name this semicircle GC? Why did he put that big space in the middle? Because the answer is no. I want to know which half you're talking about. So when you name a semicircle, you need a middle letter to denote which way you went. In this case, you have two options. You could say either GAC or GBC. Then that's the blue arc. So GAC or GBC, it's a management decision. The other semicircle is G, pick one. DC or EC or FC. So GDC is the left side of the circle. So that would be the yellow. And then that leads to what do I have to do for a major arc? Well, can I name a major arc just GA? I don't know why that moved. What is going on? Oh my gosh. I'm just going to close this. I'm having a really bad internet day today, a really bad computer day. Let's see what's left over here. Okay, hopefully that stops happening, whatever this new thing that's being thrown at me by this lovely and awesome computer. So here's a problem. When I say GA and I only use 2 letters, you got to do the most direct, closest route between GA. So that is a minor arc. So to name a major arc, I need a third letter in the middle to denote the direction I move from G. So I got to go left to make this a major arc. I can either say GF, GE, GD, GC, or GB. Oh, I'll just pick D to denote that this is a major arc bigger than 180. So here's where GD A is. It is that measure. And obviously that is a ginormous, almost 360 degrees, but not quite. So if I said GA was 30 degrees, GDA would be 330. 330 plus 30 is 360. All right, very easy stuff. And I bet you have done this before. All right, do it again. Maybe not. Even if you haven't, this is very easy. Right? There's really nothing to it. But then at the second half of this page, this is where you're going to have to focus and memorize. Okay, so mark it again. I did it again. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Now I know my ABCs. I'm just waiting. And then put an O for circle O in the middle. And then go ahead and mark those as given. So I marked an arc. Arc AB is 62 degrees. And then angle BOC is 55. And I already gave the information up over here. If this central angle is 55 degrees, then this arc is 55 degrees. Central angles are equal to the arc measures they cut on the circle. And then vice versa. If this is 62, this is 62. Because in the central part of the angle, all those angles add up to 360. On the arcs add up to 360 on a full circle. All right. All right. So, by the way, what would GA have to be? Well, what does this add up to? What does the yellow add up to become again? Everybody, 3, 2, 1, go. 180, and I think in the other hour we got 63 as the leftover by taking 180 minus the other two. I think that's right. And then the same idea. Arc GA is 63. GOA is 63. Not hard. Now, this is the thing I was trying to tell you here. So this arc is 62. What happens if I take this point? Can you see? Yes, you can. And I pull this point to the circle. What happens to this angle measure at what? It gets what? Smaller. So it's not 62 anymore. It exactly gets smaller by half. All right, and that's what you're going to have to understand about an inscribed angle. This is an inscribed angle. So that is angle EDF, which is equal to half. Let's throw in an angle measure here. Let's say that's 38 degrees up there. Then that means I keep hitting Boba Fett today. So angle EDF is 38 degrees. So arc EF, no, wrong. This is 38 degrees. So the angle measure is half of that, which is 19 degrees. That is the relationship of an inscribed angle. I always like talking about an inscribed angle right after talking about a central angle. The whole idea of the rubber band effect, all right, of how that angle shrinks when I pull the vertex off of the center. Okay. All right. So that's really the most complicated thing you can have in this basic arc measure thing, an inscribed angle. I should tell you this. If I have a circle, it's kind of hard for me to do this. And then I have this. And then I have, actually, I didn't want to make it look like a diameter. Let's say I have like this chord here and then a tangent line here. This angle measure is actually an inscribed angle. It actually is. Even though that second segment is outside of the circle, what I'm saying is this, if this was GA, I should call this GDA, and the point that it hits here is that, then this angle measure is half of that arc that it cuts. All right, that's one of the hardest questions to remember. All right, and it comes up later in our examples. Okay, now you're just going to go ahead and scratch this formula down, but I want to do it in the sense of a central angle. I almost said vertical angle, and I kind of jacked this up first hour, but I was also, my heart was racing as I knew I had a mortal enemy in my class throwing stuff at me. All right. So imagine I had this central angle. Okay. Well, then this angle is equal to the arc that it cuts. But then as I slide this off and still I'm in the inside, but stop. All right. Then what ends up happening is this arc gets larger, but then proportionally this arc gets smaller if I kept these points tethered, like these four points tethered. If I kept moving this around, the closer I make this to this arc gets smaller, this arc gets larger. They get larger and smaller proportionally. So that formula over there says this. When I change this from a central angle to a not central angle, Then what this angle measure is the average of these two arcs. And that's what that means over there. Half of the sum of those two arcs means the average of those two. That should actually kind of make sense. And when things make sense, you're not really memorizing as much. You actually solidify the formula a little bit better. I don't know if that didn't work. Guess what? You got to have that memorized. And you better have it memorized by, well, tomorrow would be nice. But you non homework doers, you better at least have it memorized by Thursday, or else you have a disaster on your hands. Now imagine this. Imagine this that I pull this arc. I just want you to think of smaller, bigger. So that is an inscribed angle. What's the relationship? What does this angle measure compared to this arc? Half. But then imagine I pull this outside of the circle. Is that angle getting smaller or bigger? Even smaller. Even smaller. And now this angle measure cuts two arcs. It cuts this arc and this arc. So I'm just going to reveal the formula, make you understand smaller requires subtraction, not addition. All right. So it's the subtraction of these two arcs and then half of that. So again, this half thing comes back to inscribed angles. Inscribed angles are half of the arc measure that they cut. When we're stuck in the inside of the circle, it's half of the average, which is sum. Now it's half of the subtraction, smaller. Subtraction means smaller. All right. By the way, this is called a secant angle because these are both secant lines. They cross the circle twice, each one of them. So secant. All right. So that's half of, and it's big arc minus small arc. Anyone that gets a negative out of this, you're a robot. You're not really paying attention to the ideas that we're having. This could never be a negative angle measure. So it's always bigger arc minus smaller. And obviously the blue one has to be bigger. And that should be obvious. All right. And guess what? None of these formulas are different. What is different, though, is what is really cut. This is the small arc. Are you okay, Mr. Samuels? No. And then the last one is a tangent, because those are both tangent lines crossing the circle once, but it doesn't matter. Here is the small arc that is cut. Here is the big arc. By the way, what are the blue and the yellow equal together in the last drawing? 360. A lot of times I have to give you just one of those, then you have to, oh wait, what's the other one? The other ones that doesn't work. Those don't, you don't know what those measures are. So it's still half of big arc minus small arc. You know what? I could literally be done with the notes, but then of course it's example time. All right, but that's it. You either get this memorized or you don't, and then we're going to move on and give you more to memorize tomorrow. Okay. Leave that up here for a second. Look around. I am okay. I just like playing a part of being mad right now. Holding on. Thinking about that person in first hour. And when I find their name, and I will, I got it narrowed down to 4. What will happen? Let's move on. Hey, what time do we get out of here? Plenty of time. Okay, you already have this drawing here. I give them the notes here to help speed up on a Wednesday as well. ER 38 degrees. OT 121. Find out. Kick them out. First hour. Nice. All right. Should have said that during the notes when I was talking. Maybe I did. Good. All right. So angle out, get out of my class equals half 121 minus 38. Let's move on. Yes. What do you mean? Are you still in? Write that. Come on. It's half big minus small. Let's go. He's so mean. Teaching in America. Teacher shortage. There's a teacher shortage. No kidding. People are chucking stuff at teachers. No kidding. Teacher shortage. Who wants to be a teacher in here when they grow up? No. Then he's like, oh, nope, nobody. Just wait. We're going to have computers because no human being is going to want to do it. Teaching in America. Anyway, sorry. Probably giving you a little too much information there. Hey, what's a diameter cut a circle in? Half! All right. So therefore, this is 132 degrees. This is too tough, Mr. Samuelus. Get out. 132. And then that means this blue one is, oh, I can't do math. Is this 50, 48? Is that right? 48. I never was good at math. I can't believe I'm doing this. All right. So then this angle, XUT, that angle measure is half. Slow down, Mr. Samuelus. No, this is honors. XUT equals half of big arc. I don't know what I'm doing. 132 minus 48. Minus. Move on. If you can't write that fast, you're anyone? Gone. Hey, what's a full circle, everyone? I don't know. Get out. 360. So I'm given 3 of the arcs. The fourth one is 360 minus all of those. So 360 minus this one, and this one. Then I have this arc measure after I do that. And then angle U, I can call that angle U instead of EUH. Angle U equals half 171 minus whatever you got for that question mark, which you would already have calculated. I just don't feel like doing it right now. Let's move on. Okay. And I don't think this is any different. You know what? I don't even feel like doing that one. Let's go to this page. All right. So then you got a smattering of questions getting this hammered down. I'm not doing all 3 of these. They're all the angles unknown. So let's take the middle one. X the angle equals half big arc minus small. And then you calculate it. Beep boop, beep boop. I'm not doing that for you. Let's go to this one. Are these highlighted or is this just I'm kind of confused. I get this from neat. You got little colors there. Oh no. What do I do on this one? This is the angle measure given. And then I have to find that arc. So that's kind of tough to see, but that angle is pointed there. So this means that arc is X. Well, its angle equals, can you see this? Half big arc minus small arc, and then you solve the equation. What I do first is multiply both sides by 2 instead of distributing. That's smart. So this is 80 equals 96 minus x. I subtract 96 and get negative 16, but negative 16 equals negative x, so x equals 16. Done. This one is an angle on the inside. Remember, if this angle was here at the center, then that arc measure would be, I don't know why I did that. I don't know why I did that. This measure, that doesn't even look like it's at the center. That measure would be 107. But once I slide it off there and move it around, that arc gets bigger, and then the other arc opposite of it gets smaller. So what do I do on this one? It's an average. X the angle equals half sum of these two, not difference. Inside sum, outside difference. You can't get that memorized? We don't know what to do with you. 16. Here's that rough one. This is kind of weird. It looks kind of like a tangent secant, and then one way you could say is, it's half of big arc minus small arc, but this is only one arc that it cuts. So what is that angle measure? It's actually an inscribed angle measure. It's just literally half that. And I guess if you thought of it as a secant tangent angle, it would be half big arc minus small arc, but there's only one arc it cuts. So it's half of the arc. I don't know, one way or the other, you got to figure out that that's what's happening with this. And then what else? That's easy. This is 80 because it's double, not equal. I'll get people that make that 40. That's not true. That's not a central angle. But I guess this one's good. What are these two measures added together just in basic geometry format? What is that? 180, all right? Yep, people mentioned in that. So I'd actually have to find this because this arc and this arc is what this, did I have X? X is here. This arc and this arc is what this angle measure cuts. So I have to get this angle measure here. All right, so that is 180 minus that, which is 60, 50, 57.5. Is that right? 57.5, because that angle is the average of these two arcs. So 57.5 equals half. I don't care if you write x first or 45 second because it's a sum. Then yet again, you'd multiply both sides by 2 and then subtract 45. The solving of this is Mickey Mouse grade school algebra. All right, so not a bad start.